Imagine standing at the center of the galaxy, not near it, at it. 26,000 light years from where you're sitting right now, there is a point in space where light itself cannot escape, where 26,000 years of Earth history compressed into a single dark well of gravity. We call it Sagittarius A star. And in 2014, astronomers thought they were about to watch it kill something on camera. An object called G2 was approaching on a collision course, a wisp of gas and dust, drifting straight toward the black hole's grip. Every observatory that could point at the galactic center was standing by. The prediction was simple. G2 would be shredded, torn apart by tidal forces, and the black hole would flare with the light of its own violence. This was supposed to be the moment, the kill shot, the proof, live and undeniable, of what waits at the heart of the Milky Way. Nothing happened. The galactic center stayed conspicuously quiet. G2 swung past the point of closest approach and kept going, undisturbed, still orbiting today. Astrophysicist Andrea Ghez put it bluntly, a gas cloud would not survive that. Something about G2 was wrong, and that wrongness is where this story actually begins. Because the black hole at the center of our galaxy is not the sleeping monster we've been taught to picture. It's something stranger, something that refuses to behave. Here's the reframe. You've probably heard Sagittarius A star described as quiet, even boring, by black hole standards. A supermassive giant, 4 million times the mass of our sun, sitting mostly dormant at the galaxy's core, occasionally snacking on a wandering star. That picture is comfortable. It's also wrong. The deeper astronomers look, the less this thing makes sense. And some of the strangest evidence has only surfaced in the last 2 years. Start with G2 itself. If it wasn't a gas cloud, what was it? Gez's team now believes it was 2 stars, a binary pair, that collided and merged into one bloated star wrapped in a shroud of its own shed gas and dust, thick enough to fool astronomers into thinking it was something the black hole could simply swallow whole. But not everyone agrees. Harvard's Avi Loeb has said plainly that we still don't know which explanation is correct, and the 2 research groups who study these objects have spent years disagreeing with each other in public. This is not settled science. This is an active argument happening right now about an object currently orbiting a supermassive black hole in our own galaxy, and G2 was never alone. Gez's team has now cataloged 6 of these things, labeled G1 through G6, all of them tracing strange orbits around Sagittarius A star. They look like gas clouds through a telescope. They behave like stars under gravity. Nobody has fully explained what they actually are. An entire unexplained population, hiding in plain sight, 26,000 light years away, orbiting the most extreme object in the galaxy. But the survival of G2 turns out to be the least unsettling part of this story. Because when scientists started watching Sagittarius A star itself, instead of the debris falling into it, they found something worse. In 2023 and 2024, Northwestern astrophysicist Farhad Yousefzadeh trained the James Webb Space Telescope on the black hole for 48 hours, spread across roughly a year of observation. He was looking for a pattern, a rhythm, some kind of repeating cycle in the flares of X-ray and infrared light the black hole throws off. He found nothing that repeated. Not once. Every single observation session showed something different. 5 to 6 major flares a day, with a constant static of smaller flickers in between, and no 2 sessions matched. Yousefzadeh described it as always bubbling with activity, never once settling into a steady state. Think about what that actually means. In more than 20 years of monitoring, across every instrument we've ever pointed at it, this black hole has never once been calm. Not for an hour, not for a single clean observation window. It is in a state of constant, patternless agitation, and nobody knows why. Now here's where it gets stranger still. In 2024, the Event Horizon Telescope, the same collaboration that produced the first ever image of a black hole, turned its instruments on Sagittarius A star and captured something in polarized light. Strong, highly organized magnetic field lines twisting around the black hole in a structure that closely resembles the magnetic fields around an entirely different black hole, one called M87 star, sitting in a galaxy 53 million light-years away. The unsettling part is the scale mismatch. M87 star is roughly 1,600 times more massive than our own galactic black hole. These two objects should not look anything alike, and yet their magnetic architecture appears to follow the same design, as if there's some universal blueprint stamped onto every black hole in the universe, regardless of size. That resemblance matters because of what M87 star's magnetic field is known to do. It powers a jet, a beam of particles blasting out from the black hole at nearly the speed of light, visible across intergalactic distances. If Sagittarius A star shares that same magnetic structure, the Event Horizon Telescope team has raised a genuinely disturbing possibility. Our galaxy's black hole might be hiding a jet of its own, one that's never been detected, one that could, theoretically, be pointed somewhere we haven't thought to look. A weapon we don't know is loaded, and the black hole doesn't just hide its present activity. It's left records of its past, written into the gas clouds, scattered around it like a memory it doesn't know it's keeping. In 2017, a research team led by Eugene Shirazov reconstructed a flare from Sagittarius A star's history using light that had bounced off a distant molecular cloud and was only now reaching us, over a century after the original outburst occurred. The black hole flared once, roughly 110 years ago, and we are only now watching the echo of that violence arrive, replayed in reflected light from a cloud light years away. That's not the only echo. A separate study, led by Gabriele Capelli in 2012, went even further back, using iron emission line reflections off nearby molecular clouds to reconstruct Sagittarius A star's X-ray brightness across 150 years. What that reconstruction revealed is that the black hole used to be dramatically brighter than it is today, not in some ancient cosmological epoch, within the last century and a half. Within human historical memory, this thing changed, and we have no complete explanation for why it dimmed, or what triggered the outbursts before it did. So it never repeats. It's never calm. It's brighter in the past than in the present, for reasons we can't fully explain. It might be hiding an invisible jet. And now, buried in the data, there's something even stranger waiting. In 2023, researchers Yoshua Magallanes Gijon and Sergio Mendoza at the National Autonomous University of Mexico went digging through 9 years of gamma-ray observations from NASA's Fermi satellite, more than 860 days of data, over 1.5 million minutes, hunting for any hidden periodicity in the black hole's output. What they found was tentative, unconfirmed, but almost impossible to ignore. Evidence of a quasi-periodic signal, a rhythm pulsing roughly every 78 to 96 minutes. If that holds up under further study, it means something is beating at the center of our galaxy. Not randomly, not chaotically, like the flares Yusef Zada watched for a year. A rhythm, a pulse ticking away at the edge of the event horizon on a timescale close to 1.5 hours, for reasons nobody has explained. We used to think we understood this place. A quiet supermassive black hole, dormant, predictable, 4 million solar masses of settled darkness at the center of everything. What we actually have is an object that survived a predicted execution, that hosts an entire unexplained population of star things disguised as gas, that has never once repeated itself in 20 years of watching, that shares its magnetic fingerprint with a black hole 1,600 times its size, that may be firing a jet we've never seen, that was measurably brighter within living historical memory, and that might, if the data holds, have a heartbeat, 26,000 light-years away. At the exact center of the galaxy we call home, something is still flaring, still pulsing, still refusing to settle into silence. We are only now learning to listen closely enough to notice. And the longer we listen, the less it sounds like nothing is happening in there at all.